Hello everyone. In this video, we are going to talk about trapezoids and kites. This is chapter 6, lesson 6, by the way, the last lesson of the chapter. First, we are going to talk about properties of trapezoids. So, most of you probably know how a trapezoid look like. I'm going to talk about this figure right here. The sides at the top and the bottom. In other words, if the sides that are parallel to each other are called base. And the ones on the sides, RS and TU, are called the legs. So, I didn't realize that it was in here. So the left side and the right side is called the legs. So these small lines indicate that the legs are equal in length. That means the trapezoid is an isosceles trapezoid. So if the sides are the same, if two sides are equal to each other, then it's called an isosceles trapezoid. And right here, let's go over this part. The midsegment or median of a trapezoid is the segment that cuts the legs in half. So, and it's equal to, let's say, let me just explain it over here. Let's say we have an isosceles trapezoid over here. The legs are the same. The bases are parallel. So if we have the midsegment right here, if I label the points, E and F, let's say these are A, B, C, D, then the length of EF would be equal to AB plus DC divided by 2. Basically what this says, since this segment is going to be in the middle of the trapezoid, exactly in the middle, it's kind of the average of the top and the bottom side. So average means add them together, divide them by 2. Or if you do cross multiply, this formula becomes this. 2 times EF equals AB plus DC. So let's real quick have one example over here. It's not here, but I'm just gonna make it up. Let's say we have a trapezoid. This side is 10, this side is 16. And we have the midsegment. We know it's midsegment if it is given when we have an isosceles triangle, trapezoid, obviously. So the length of the midsegment is going to be 10 plus 16 divided by 2. So 10 plus 16 divided by 2, which is 13. Or if it is 10 plus x, and if this one is 3x, and then this is what we would do. Add the bases together, just like what we did over here. 10 plus x plus 16 equals, divided by 2 equals 3x. And then we would do cross multiply and solve it. Now, let's just go over this one here real quick. 10 plus x plus 16 becomes 26 plus x divided by 2, which is equal to 3x. Cross multiply. We have 6x on the right side, 26 plus x on the left side. Subtract x, so we get 26 equals 5x. If we divide it by 5, we get x equals 5.1, So that's how we can find the midsegment, or a variable that is about a midsegment of an isosceles trapezoid. Now, let's talk about this question, this example over here. It says the vertices of ABCD are given ABC and D. Show that ABCD is a trapezoid. So it is known that it is a trapezoid, but we need to show that and determine whether it is an isosceles trapezoid. So in a trapezoid, the rules are this. Only one pair of sides are going to be parallel. So if you look at the figure, BC and AD are parallel. That's obvious, but we need to show that by using the coordinates of the points. When you don't have a figure on the coordinate plane, you gotta draw a random quadrilateral that looks like a trapezoid, like this. Label the points A, B, C, D, and then try to show only two opposite sides have the same slope. So now let's find the slope of this one, BC. So we find the difference of y values. They are both 3, so the difference is 0. And then subtract the x values. Right here, subtract the x values. 2 minus negative 1 is 3. Now let's find the distance of AD, slope of AD. Subtract the y values. Since the numbers are the same, the difference is 0. And subtract the x values. 4 minus -3 is 7. So they might look different than each other, but they are not, because 0 divided by a number is equal to 0. So both of these have the same slope. So that means side BC is parallel to side AD. So what we say is, since BC is parallel to AD, these are segments, ABCD is a trapezoid. What about being an isosceles one? So because the question has two parts, the first one is about being a trapezoid, the second part is about being an isosceles trapezoid. Remember, in an isosceles triangle, the sides that are not parallel to each other, in this case, these are the ones that are not parallel. Or actually, sorry about that, I just realized that I didn't even figure out their slopes. For us to say this, for us to write this, we need to see that the other slopes are different. So let's continue and find the slope of the left and the right side. They must have different slopes. So side AB, right here, let's find the slope. 3 minus -1 is 4. And -1 minus -3 is 2, which is positive 2. This is a positive slope. Now let's find the slope of CD, the last 2 points. The difference between the y coordinates are -1 minus 3 is -4. And subtract the x values. 4 minus 2 is positive 2. Now look at the slopes. This one is positive, this is negative. They cannot be equal to each other. That means we only have one pair of opposite side parallel to each other, which makes this figure a trapezoid. Since, let's just add one word over here, since only segment BC is parallel to segment AC, because it must be only one pair of sides, ABCD is a trapezoid. Now, how do we know if this is an isosceles trapezoid? So let me just choose another color. This side must have the same distance as this one. So let's figure out their distance then. Side AB has the distance of, it has these two coordinates. Find the difference between -3 and -1. The difference is 2. Square that number. And find the difference between the y values. From -1 to +3, we gotta go 4 units to the right. So the difference is 4 units. We don't even need to calculate this one, actually. Let's just figure out the other side. We are done with AB. Let's see if CD has the same numbers under the radical. So let's focus on C and D. Subtract these two numbers. The difference between 4 and 2 is 2. Square that. Do the same thing for y values. From 3 to -1, we need to go 4 units to that way, to the negative side. So as you see, this one and this one are exactly the same. That means they're equal, by the way. But just in case, let's write, this is radical 20, this is radical 20. So now our reasoning is, since AB is equal to CD, or you could say the legs are equal to each other in length, ABCD is an isosceles trapezoid. So that's all for this. First, again, you need to prove that only one pair of sides are parallel. The others must have different slopes. And then you need to show that the legs have the same length to say it's an isosceles trapezoid. Okay, let's real quick have 2 more examples about trapezoids. So I will explain one more property when we are talking about this example, by the way, because I just skipped that. I didn't realize. Okay, now this trapezoid is called isosceles because the legs are the same. As you realize, the legs are 5 units long. That means right and left sides are equal in length. The bases are parallel, so that means this is an isosceles trapezoid. So here's a shortcut that I use. This angle is an acute angle, and this one is an acute too. And these two angles are obtuse angles. So in an isosceles trapezoid, acute angles are congruent and obtuse angles are congruent. So obviously these two pink angles are going to be 40 degrees. So you should remember that in an isosceles trapezoid, the acute angles are congruent, the obtuse angles are congruent. These two are called base angles, by the way, and these two are called base angles too. Now, there's two different ways to figure out the orange angles, by the way. The first one is using the property of having consecutive angles equal to 180 degrees. These two and these two, they should add up to 180 degrees. That means if you subtract 40 from 180, you get 140, which is equal to one of the orange angles. So this one is 140, this one is 140. Or if you just add these four angles, you will see that you get 360 degrees. This is happening because the figure has four sides. That means the sum of the angles of this trapezoid is going to be 360. So the figure was like this: 40 degrees, 40 degrees. These two were missing. We knew they were supposed to be equal. So what we have in the figure is 80 degrees. We have 40 plus 40, which is 80 degrees. But we know in total they must be 360. If we subtract it, we get 280 degrees. Now this 280 is the sum of these two. If we basically divide it by 2, we can get one of their measures, which is 140 degrees. So there's two methods to figure out the missing angle or angles of an isosceles trapezoid. So this question was about the measure of angle L, which is 140 degrees. Now here's the last one. For trapezoid HJKL, M and N are the midpoints of the legs. So that means M cuts this segment in half and N cuts this one in half. So let's just put it on the figure. HM is congruent to ML, is congruent to JN and MK. All of these are congruent. Now, HJ is 32. The base at the top is 32. LK, the base in the bottom, is 60. If you remember the formula that I told you about finding the measure of midpoint, the one in the middle, we find the average of these two bases. 32 plus 60 divided by 2, which is 92 divided by 2. If we divide it, we get 46 for the length of MN. Now, let's talk about kites. Kites look like kites, as you can guess, and they have a couple properties. The most important ones, I guess, the consecutive sides are congruent. MN is the same as NP, and PR is equal to RM in length. But they're not all equal to each other, and opposite sides are not parallel. They're not supposed to be parallel. There's no parallel sides. Opposite sides are not congruent. Just remember that, because I don't want you to get confused. Parallelograms, rectangles, rhombi, and squares, they all had almost the same properties, but kites are kind of different. And other than what you see on the figure, we have two more properties. The first one is the diagonals MP and RN are perpendicular. That means these angles are right angles. All these four angles, they are right angles. The second one that I want to mention is opposite. Only one pair of opposite angles are going to be equal. So let's say angle R and angle N are different than each other. Then in that case, we will say that angle M must be congruent to angle P. And one more property, I just realized it's not in here. This length is equal to this length. So whatever that point is, let's say this point is S, MS is going to be congruent to SP. So that's another common property that we might use. Okay, let's get to the example here. It says if WXYZ is a kite, find measure of angle Z. So now we have 4 angles. As you see, the sum of the angles must be 360 degrees because quadrilaterals should be add up to 360 degrees. Now the angles that we know is 80 and 60. Since they're not equal to each other, as you see, these are not equal, they're not congruent, these two angles must be the same, whatever that is equal to this one. So the angles that we have is 80 and 60, right? So if we add them, we get 140 degrees. But this is not enough for us to get to 360 degrees. Let's figure out the distance between the sum of all these angles and what we have. So if we subtract, we get 220 degrees. So this is the sum of angle X and angle Z. Remember, let me see where the properties, exactly one pair of opposite angles is congruent. In this case, that pair is these two angles, they're equal, and their sum is 220. If we divide it by 2, we can get one of their measures, which is 110 degrees. The question is about angle Z, it is 110. Here we have the last example about the kites. This is one of the best that I like actually. It's about Pythagorean Theorem. Usually the questions that you will see about kites are going to be about Pythagorean Theorem. For those who doesn't remember what it is, it's a squared plus b squared equals c squared. These are the legs. This one is the hypotenuse. So now let's look at the question. The next property that we need to keep in mind is the diagonals BD and AC are perpendicular. So this angle right here is 90 degrees. So that means this triangle right here, this triangle is a right triangle, which means we can use the Pythagorean theorem. Because the side that we need to figure out is BC, right? This side. We need to figure this side out. We know one of the legs, let's say this is A, is equal to 5. The other leg is equal to B, or 12. The missing side is, let's say, C. So the formula is A squared plus B squared equals C squared. A is given 5. We are going to square that. B is given 12. We are going to square that number 2 and then try to figure out the length of the hypotenuse. 5 squared is 25 and 12 squared is 144. Right hand side stays the same. We combine the like terms. Oops, sorry about that. We combine the like terms on the same side. These two, which is 169. Right side again stays the same. Now we need to get rid of this squared to get the variable by itself, which means we need to do square root radical to each side. The right hand side is C, left hand side radical 169, which is equal to 13. So that means the length of C, or BC, is equal to 13. And I guess we are done with this question and the video. Yeah, we are done with the video, guys. Please comment below if you have any question. Thanks for watching, and I will see you in another video.